Hi, my name is Samuel, and in this video we're going to be going over how to set up my Fedora 42, for I wanted to upgrade my laptop you see behind me. This would actually, so by the end of it, you'll be able to jump between 4 different environments to see Paragon behaving nearly exactly the same across all. So right now I just booted up into Fedora 42. It's a completely new slate, and you're gonna see me bring up a couple windows. Usually I put all my repositories in a Git folder. So right now I'm going to try get cloned, but looking back at the recording, I missed a K. So I'm just navigating to the GitHub repo. And I'm just being lazy and just copy and paste the link in. There we go. Now I can just CD into it. And first we need to enable so we can actually run the setup script, which basically installs like Python, Node.js, Ionic, Golang, and the GCC compiler, so we can actually hit the ground running. And it automatically updates as well, so that's pretty cool. So as it runs, we can go. I'm just scrolling through the actual GitHub. And I think this machine is my ASO Nitro 5 with AMD, and so I won't be using any CUDA or anything, or any AMD sort of proprietary AI stuff. It's all WebGPU. Just gonna name my device here. I'm not even sure what the setup process is to actually use the AMD stuff. Oh, also installing Bun as well. I tried installing Node.js and Bun and trying to run the WebGPU straight from the WebAssembly, and I found out that they both don't actually have WebGPU enabled, and so I think Google created a project called Dawn, which probably talks straight to their C ABI pipeline, which then talks to the WebGPU.
Sorry, I didn't understand.
I wasn't talking to you. Okay. So now it's installing. It's installed the Python and Paragon and Jupyter notebooks and a bunch of other things as well. So that's awesome. So we're just going to go to notebooks and set up a Jupyter notebook. Then we can basically hit run on the Vision folder, and it will train the model that we need for this microservice demonstration. And then I'm just going to check if Bun and everything else is installed properly. So I'm just going to check if the benchmarks work. There we go. So you can see the actual AI framework running in Bun. Then I'm just going to install the microservice and actually just get that up and running. Just by npm I and then npm run dev. but I'm just going to go back here and get the Python microservice running, see if it works with the benchmark as well. There we go, everything looks good. And I forgot the commands to actually set up the microservice. So I'm just checking my own README again. So, yeah, that's right, I set up that you just go pip install -e dot, which installs from all the requirements, I think. And then we can just run the actual service. So what these microservices do is they just basically check if you can actually, if the model's not there, it'll just create it, and then load it in and check GPU and CPU, running through the same sort of 9 samples. And that's the end goal. So now we're just going to get the Golang running. It's done training the model as well, so that's pretty good. I trained fast before I can set up the actual dev environment. Just checking if everything's running. And Golang. Oh, there we go, the benchmarking works in Golang as well, so that's good. So then we can just go to the microservice and get that running. Just going to go out of the folder and then going to pivot into the Ionic, the front end now. Just going to do npm-i to set up the actual thing. It's running Bun. It's so much faster in Bun. And then, yep, we've got the Ionic running, so we're just going to check if it's set up correctly. Everything should be fine. We're just going to go to demo, check if the AI framework runs in the browser through the portal npm-i thing. Yep, works. Then we go to Mist. So here we're going to be testing the 4 different environments and that. So Node.js, Python, and Golang. Just checking if the model's there. And there it is. So yeah, so the 4 different environments, they interact with the Paragon AI framework in different ways, but it's the same sort of AI framework code just running everywhere. I'm going to try and talk to all the services. And there's an issue with the Node.js one. So the front end depends on the Node.js loading the model in and the actual stuff, so I'm just trying to refresh. Trying different numbers. And as you can see, the each microservice has set up its own individual model, so you're getting different results across the board. I mean, that's Then realizing that the Node.js needs to be running on port 8001, not just 8000. So I should probably update that. So we're just going to be starting it on the right port this time. So it's loaded the model in. We're just waiting for that Paragon ready dash model. And there we go. We at least have the 4 microservices at least talking now. So I'm just turning off all the services now because we're going to be simply just copying and pasting the same model, and it's going to be running in all the 4 same environments. And I accidentally turned off the Ionic website. So I'm just going to go to where the model is actually trained. That was in here, and into the notebooks. Vision, and there's the model. It's 21 megabytes. So I'm just going to be copying it into the Golang folder. That's where the microservice lives. Then we're going to be copying it over to the Node microservice as well. Replace that model. And lastly, the Python microservice. So we're going to be replacing that model as well. So just going to start up all the models, all the microservices. So it should reload the actual models, the new models across the board. So then we can see the identical behavior across all 4 environments. So it's important because this is a significant milestone, because Node.js has its own sort of, I think it's V8 engine, which runs, TypeScript and other things like that. Then you've got Python, which talks to the CABO pipeline, which then you got Golang, which is native. Then you got the Wasm/Portal, which is the browser. And that's so very 4 distinct environments, and we want to have the same model without converting, running across. So there we go. We have 3 of them running with the same inputs and outputs, and there's and I forgot to actually create the actual neural network in the front end, so which then created uncertain error, which I'll just refresh the actual, I'll just rerun the actual thing. It should resolve. So as you can see, the front end doesn't match up with the other microservices yet, because we're waiting for the Node.js environment to load up the model. So I'm just going to stop it here and then just restart it. Oh, that's right. I think I installed the Vulkan stuff as well, just in case it needs it. Other services are running. Now we just need to get the Node.js up and running. And not to forget the port. Might just update that. Might just update that now actually. Now we're just waiting for the Node.js to start up. Nearly there. So we're just going to load the model in from the Node.js into the front end. Right now it lags the actual interface, but I'm sure if you put that onto another thread or an asynchronous thing, this will help. I wonder what the larger models are going to do. This is only 21 megs. And there we go. We've got the same model running across 4 different environments without actually doing any model conversion. So that's pretty awesome. Here we can see down to the decimal point. I'm sure as you go further down the floating point sort of chain, you'll see some discrepancies and stuff like that, but it's just awesome. And to test against those microservices in the command line, I just run the test parity sort of script, which is over here, which works fine against if you just change the port you're pointing it towards. And there we go. Everything's set up. No CUDA, no anything. And no AMD. So, hope that's helpful if you want to replicate the same dev environment and have a play around. Thank you.